Hello, I'm Phil Lintelak. I'm on the faculty at the University of Vermont in plant biology, and I wanted to put together a number of short video segments to demonstrate some of the simple methods that I've put together over the years for working with microscopic samples and some other things that I think would be helpful to people, and I just want to get them on record so that I can distribute them. And so today I'm going to talk about a simple method for constructing what you might call microculture chambers that can be used to observe living specimens on the microscope stage for extended periods of time without having them dry out, and that preserves them alive and in good condition. They're very easy to construct once you master a few simple methodological tricks, and I just thought I'd take this chance to see if I could demonstrate these for you. Okay, so as I mentioned, I'm going to show you how to make a microculture chamber for keeping living specimens alive on the microscope stage, sealed in a chamber so they won't dry out, and presumably able to survive for extended periods of time on the microscope stage. And I've found this to be a remarkably useful little method, and easy to do and inexpensive. And for instance, here is a culture chamber that we made a little earlier. We can make them in different sizes and different thicknesses, and I'll show you how to do that. It takes a little bit of practice, but it's really quite easy to do, and anybody can do it. Anybody can do it if you have the materials. So let me introduce the materials to you. And perhaps the most useful of these is this material that we call Valap, which is a mixture of Vaseline and lanolin and paraffin in equal parts. And the Vaseline is easily available at any pharmacy. It's inexpensive and non-toxic. The paraffin is also equally available on any supermarket, on a supermarket shelf. It's also inexpensive and easily available and completely non-toxic. And lastly, we have lanolin. Lanolin, you can get lanolin at a pharmacy in small tubes, and that's great. I like to buy it in slightly larger quantities because I use this material all the time. This is available from one of your scientific supply houses like Fisher or VWR, and it's not expensive, and it keeps well, and so you mix equal parts of these together and melt them so that they melt together, and stir them up, and you get this material that we call Valap, and it keeps forever. It's totally non-toxic, and it can be autoclaved. It'll store here. I always keep some on hand because I find that I'm using it all the time, and it's an excellent material to know how to use. I have a little container of it here on my hot plate. I melt it up to just about 100 degrees centigrade, and it melts very nicely, and I can apply it with a Q-tip very easily. So the second thing that I need to show you how to do, well, I need to show you a little bit about some of the other materials here. We have obviously microscope slides that we use to construct these chambers with. These are your normal 1 by 3 inch microscope slides, and everybody's familiar with these. And they're easily available, but I like to use larger, slightly wider microscope slides. These are 1.5 by 3 inch slides that are easily available, again, from any scientific supplier, and you can even get them larger than that. Perfectly easily available if you're willing to to go to a scientific supplier. And the same thing holds true for the cover glass. The familiar square cover glasses or circular ones are easily available, but I tend to favor the larger rectangular ones. These are 22 by I think these are 22 by 40 millimeter cover glasses, and they're very nice, and they obviously you can cover a slightly larger specimen, but they also just give you a little more room to work with, and I'm going to be using these partly today to construct the foundation for this little culture chamber. But cover glasses also come in even larger sizes. You can get them in these very large sizes like this that are ideally suited for you for working with the very large microscope slides. And if you use this kind of method, you could make temporary or permanent mounts of quite large materials this way, suitable for observation on the microscope stage. Okay, so let me set these aside here. We're going to be working with the rectangular cover glasses and these 1.5 by 3 inch slides. Okay, so let me show you how to break the cover glass. What I'm going to do here is I'm going to use a diamond-tipped scriber to score the cover glasses so they break into narrow strips, and those narrow strips are going to form the support for the overlying cover piece, the overlying cover glass, and they'll form the culture chamber itself. So I'm going to take my diamond scriber. These are not expensive either. You can they're relatively easily available. But the trick is in scoring the cover slip without fragmenting it into a multitude of little pieces. So what you want to do is you want to start with one smooth motion, starting just short of one edge and running down to the other. There's one piece, and they don't always break off spontaneously like that, but there's 2, 3, 4, 5, there we go. Now the trick here is to, you don't want to press too hard or you will shatter the cover slip. And the other part of the story is that you want to apply just enough pressure in one smooth motion, because what you're actually doing is you're plowing a groove in the glass. The diamond is harder than the glass, and so if you use it correctly, you're not generating a lot of cracks. You're actually plowing a groove in the glass. So you want one smooth motion. You don't want to scrub back and forth. And what I like to do is I like to start just short of one edge and finish my scoring stroke just short of the other edge. If you run the diamond over the edge of the glass, it tends to break out small fragments of the diamond over a period of time that will degrade the tip of your diamond. So I start just short of one edge, and with one smooth stroke I go just short of the other edge, and that should provide a nice crack that will break off very nicely. And these pieces, if you do them right, they're quite strong. You can actually bend them and flex them. If they don't have little micro cracks coming off the edge, they're quite strong. And so there I've got my basic pieces that I will use to construct the framework for this little culture chamber. If a couple of pieces don't break quite right, no matter, you just break a few more. Okay, so I've got my basic pieces there. I'm going to need 4 of them to construct this little chamber. There we go. And now I'm going to place them on my microscope slide in the orientation where they will form essentially form a little box that will be the basis of my culture chamber. So I'm going to put 2 there, and 2 along the ends, like so, like this. And so this is going to form a very nice little box-shaped support for my cover piece. Now, okay, so here they are. That's approximately the location they're going to be in. Now what I'm going to do is I'm going to take my Valap and I'm going to tack them down in place. I'm going to take them, put a little dab of Valap on them like that, and place them in their approximately final location. 1 of them, 2, try to handle them carefully, but if they're well made, they're fairly strong. There we go. Okay, that's the approximately final location for them. Now what I'm going to do is I'm going to place them on the hot plate. I like to put a Kim wipe down so that it keeps the slide clean, and I'm going to allow them to melt down in place there. You can watch the Valap melt underneath them, and there they are. So there, while they're still melted, I can move them a little bit, get them into their final location. If I need to remelt them a little bit, that's not a problem. I can remelt them a little bit there. And there they are in their final location. Very nice. Okay. Now I have to make the cover piece to go over them. So that's basically the little culture chamber. It's formed there. Now I need a cover piece, and I'm going to make it so that it's just a little shorter than the length of the chamber as a whole, so the cover piece doesn't overhang the edges. And the reason for that is it makes it easier to seal at the end if it doesn't overhang the edges. Again, I'm going to start my scoring stroke just a little bit short of one edge. And run it down to the other edge. That didn't quite. Sometimes the diamond gets hung up on the edge of my guide piece and doesn't actually contact the glass. There we go. So there's my cover piece. It's going to go on like that. There we go. Now, so now, if I have my living material available, I'm going to place it in there, ready to be covered. If it's in a culture medium of some sort, I can just put a few drops of it in there, and the cover slip should lay down on top of that very nicely. And then I can place my covering piece over them like so, and what I'm going to do is I'm going to tack it in place with a little drop of Valap in one corner, a little drop in the other corner, and then I can seal them in with one stroke of the Q-tip, sealing them in very nicely like that. And my last one there. Okay, so there I have my culture chamber. That's all there is to it. It's done, it's finished. I've presumably got my living material inside. It's sealed up nicely. It's totally non-toxic. It's easy to do. It's inexpensive. It's a very useful thing to know how to do. Now, the only question is, what happens if I have material that's thicker than that? Because here I've used cover slip thickness only for this, and there are several things I can do. I can take several layers of cover slip and build them up so that I basically have more than one layer of cover slip to support the covering piece. And I can lay them on there as I did before with a little dab of Valap. I'm just going to make a demonstration piece here on the side. There's one. There's two. Lay them on top of each other. And then I can melt them together as I did before. And there they go. They're melting together. And so now I have my double thickness cover slip there to act as a support. But under some conditions you may find that you have a material that's even thicker than that. And so I want to show you how to make supports using not cover slips but microscope slide itself for the support. And the microscope slide is obviously considerably thicker, and so it makes for a deeper chamber. And if you get, once you learn how to break the cover glasses, breaking the microscope slides is a similar proposition, but it's a little bit different. So let me show you how to do that. I'm going to make my supporting pieces out of a microscope slide here. I'm going to make them a little bit wider, the supporting pieces. So again, I'm going to make one smooth stroke just short of one edge and ending just short of the other. One. I'll see if I can do them all here. Two. Three. So that should give me 4 pieces. 4 pieces there. Now to break them, instead of just breaking them with my fingers, I'm going to lay the scored piece over the other slide with the scoring mark just over the edge. And with 2 fingers there and 2 fingers there, I can break off one piece. 2, that didn't break too well, but I can make another. 3. 4. Here, I'll break a couple more so that I have my 4 pieces. 1, 2. There we go. There. And there. So there I've got my 4 supporting pieces. And now I'm going to take one of these slides. I'm going to do the same thing as before. I'm going to arrange them in their final orientation like this. Make them like this with the side pieces going here and here. So they're going to end up in an arrangement something like this. I can adjust the width as I need to, and I'm going to do the same little routine of tacking them down with Valap, like so. There we go. I try to avoid getting Valap on the central portion of my culture chamber, on the part that you will be observing through, because obviously smears of Valap on the optical surfaces don't help your imaging ability. So now I'm going to melt this down for a moment on the hot plate. And there it goes. Should melt down quite nicely. I can rearrange it here. Before it cools too much. Must have a piece of something under that one because it's not lying flat. And I think I see a piece of glass under it. So I will do this again. There we go. All right, there they are. There are my 4 support pieces. Now, after letting that cool for a moment, I'm going to construct my covering piece as before. I'm going to make it just long enough, but not overhanging the ends. There they are. Again, I'm going to tack it down. Got to let that melt again. So there's a chamber that is now deep enough so that it can contain a slightly thicker piece of living material, and it's basically just as easy to produce as the thinner one. Easy to do. Now, the interesting thing about this is that all of these materials can be easily sterilized. The cover slides, the slides and cover slips can all be autoclaved. The valap itself can be autoclaved repeatedly. There's no problem autoclaving valap. It's not volatile, and it won't cause any problems, and it can be kept in a sterile condition. The only other trick that I like to do when I'm trying to do this under aseptic conditions is to locate my basic pieces in a chamber where they are easily accessible. So I will autoclave them in a chamber something like this. In this case, I've constructed a little block of Teflon with grooves in it so that it holds the pieces upright, because when you're working in a transfer hood or a laminar flow hood and you're trying to, under aseptic conditions, pick up a cover slip that's lying flat on the bottom of a petri dish or something, it can be very difficult to do without contaminating it. So I have this grooved block so that it's easy to pick up my pieces from inside their autoclaved container. Okay, so there they are in there. I can arrange them, and then they're easy to get at. So meanwhile, this piece is ready to tack down. Tack it down in one corner, 2 corners, and again I can go around and seal my little chamber very nicely, making sure that I get all the corners so that my specimen will not dry out if I'm leaving it there for an extended period of time. I've used this method to conduct extended time-lapse studies of materials. A couple of years ago I made some time-lapse studies of sterile fern gametophytes growing right on the microscope stage. I had the same specimen growing for a week and a half. Right on the microscope stage, it grew very nicely, and 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 was easy to follow. Very easy method. Thank you very much.